We've got 73% is part of that national survey. Okay, now there is, for this university, what is the statistic for this university? It's
72%.
132 over 200.
132 of SROs?
132 out of 200, right? So take a minute and carry this calculation out. 132 out of 200. And I don't even think you need a calculator for that, but maybe you do. Cutting 132 in half is the same thing. 66, right? 0.66. Okay. Now, I keep recording this out of the frame. Exactly. How is he supposed to get his information? So, we calculate our statistic over here. Before we do a stat test or a significance test, we got to make sure 3 conditions. What are they always?
Random,
normal, independent. Okay, does it say random in there? SRS means random. All right. The normal. So we want to do 0.66. Oh, I'm sorry. For this one, we're doing 0.73. We always go back to the original statistic. 0.73 of the 200.
Can you focus that a bit more?
Sure. Better? 0.73 of the 200 is going to be a big number.
146.
Yeah, about 150 almost. How about 0.27 of 200? 54. We need those to be bigger than 10 in order for it to work. And independent is that 10% rule. So does this say something about it being a large university or a state university? Do you think that 200 is smaller than 10% of the amount of first-year students at a state university? Mm-hmm. I'm going to venture to say yes, because if it's a no, we can't do it. So obviously, if I'm going to have to do all this calculation, it's going to be exactly. So
Are we using the probability of the actual sample?
we use the national. We use whatever is supposed to be the expected value of the 200. Why do we do that?
So we're checking the notable probability of the sample.
I will check, but I know that it's 0.73. Okay, but I'll check as to why. Okay. I always get back to you when you got good questions. So I will check as to why we use the statistic in there, or we don't use that statistic of 0.66. Yes, sir.
That is like a check to make sure we can do whatever.
Exactly.
So
It's got to be greater than or equal to 10.
RNI.
RNI. You got it. We've been doing that for even in chapter 8 we had to do that. In chapter 7 we had to do that.
Where's the bins?
Binary, yeah, successes and failures and stuff like that. Yeah, a little different, but similar. Let's state our hypothesis. Yes, yes, sir. Where it doesn't work.
Yeah, what do you write if you...
So if it's not
I think there are problems in the book that say state why it doesn't work. Like, why can't you do a test for it? I think if you look on that test, did I include one on this test? Number 3, I think, was the defective chips have been violated. How come the conditions were violated on it? Like, which one doesn't work? So that when you go to perform the test, you can't calculate it. That's the way it would be worded. Something like that. Like, how come you can't do the test? Not do the test, and then when you're not supposed to, say, ha-ha, you weren't supposed to, trick question. Something like that. So, what do you think, what do you expect to happen? What's the national value? Because that's kind of what you expect to happen.
0.73.
73% or 0.73. Now, I'm going to keep this as P. .73 is what we're expecting. I was using PO and PA before, and it confused people, but it's the same type of thing. I just want to make sure that we can differentiate when we go to put it in the formula. That's why I was using it, because certain places use the PO, and then I didn't want you to get confused there. But so when we look at this, we're saying, is there good evidence that the proportion of all first-year students at this university who think being very well off is important differs from the national value of 0.73 or 73%? So our hypothesis that we think in the beginning is that it should be 0.73. What's the alternative hypothesis?
Doesn't.
That it doesn't equal 0.73. Now, we're not saying lower than 0.73. It doesn't say on there what's the proportion who are lower than 0.73 or greater than. It says who are not 0.73. So we're actually going to be doing the two tails like we did in class last time, where we're going to find out what the proportion is here and add them together. So that's why in the last one, when we were in class, we times it by 2, the proportion in the end, or the probability in the end. And I put also on this problem what that alpha is going to be. Remember that 0.05? So if it happens smaller than that, it's so rare, it's just not possible for it to happen. So that's kind of what we're looking for. That's that borderline. Do you remember the formula? The cute little Z formula. So it's just standardizing it, and we call it the test statistics. It is the probability, the p hat, what we got, minus what we're supposed to get, our expected value. And then you got to do that whole thing down here. And all of this is dealing with 73%. 73%. The only time we use p hat is right in here when we're trying to incorporate it in and see what happens. So this is where we do 7.3 and the opposite of 0.73. 0.27, and then the amount of people.
Do we have to memorize that equation?
I think that equation is on your formula sheet that I just passed you back. Not this whole equation, but as far as this bottom part of this equation, I believe. Now, if we look through, might be there as well. That is the Z-score formula, yeah. It's just the Z-score formula. I don't think it's yeah. All right, let's do some math. 0.66, take away 0.73. It's going to be negative. Make sure you always square root the bottom part too. If you forget to square root it, it kind of throws everything off.
No, I was like,
Alright? 0.73 times 0.27 divided by 200 square rooted. And then we'll divide. What's here? Be careful. Cocktail fun.
So you multiply this by
And then
it just says here these.
this is for I got negative 2.22982, something like that.
I rounded it.
This probability.
Oh, I like 924.
Then you take this.
Multiply by 2 times negative.
There we go.
Compare this to this.
Got it. Hey, use that table. Find out a z-score of negative 2 point. I'm going to use 2.23.
If you multiply twice
The z-score is negative 2.2.
multiply it after you go through
Oh, no. You multiply it after you go through the chart. You find out what the negative 2.23 is.
Why is it do that? Siri, no.
It's less.
Yeah, so be careful because we get. Yep, make sure you have all the zeros in there and everything like that. Now be careful because when you're doing this is just where it doesn't equal 0.73. This is only one portion of it. So we need both portions of it. We actually have to multiply this by 2 because this is only one of those tails. We need to count it twice. So it's probably going to be something like 258, something like that.
Is there a P before those parentheses on the bottom? It's kind of-
Yes. Okay. So now we do the comparison. So think back when I passed out cards, okay? And I was passing out the red cards. I keep going back to the analogy because I think that analogy is what is going to keep you grounded in the situation. Okay? I passed out one red card. No one thought anything of it. That was about a 50% chance. I passed out another red card. Let's just pretend that I kept putting that old red card back. That would be, what, like a 25% chance of getting 2 red cards. Because you do 1/2 times a half. If I did 1/2 times a half times a half, and 3 red cards in a row, the probability is getting really low. Once I did 4 and 5, remember I keep mentioning, Courtney and Alyssa were like shocked. Will, after like 8, said, forget it, this is impossible, show me a black card or I will not continue. Okay? Same type of thing. Now for this, the chances of this occurring are 0.02 for your chances. So like 2.5% is the probability of this actually occurring. We say that our cutoff is 0.05. So anything lower, even if it's 0.049, even though it's not that far off from a cutoff, that is our cutoff that we have to use. So when you look at this, is this something that could possibly happen? We say this is very rare that this could possibly happen. Sometimes I kind of jot that down to keep myself in check. This probably cannot happen at all. It's like Michael Jordan taking free throws, okay? He's Michael Jordan. If I take 3 free throws, he's absolutely, even on his worst day, is going to beat me on my best day, okay? There's no way that you can just say, well, it's possible he could get a certain amount. No. If we're talking about someone like that has a set percentage rate that they usually throw at, they might be a little bit lower or a little bit better, but they're not going to be so drastic that they do as well as a math teacher in Alden High School or something like that, okay? Or the percentage is going to be so rare that could ever happen that we would kind of just conclude it from that. So when you look at this, we're saying this probably didn't happen. So this is this HO here. So right now, hopefully you're thinking one word where you're saying it's not happening, so we reject. You got it.